What is this polarity effect in covalent bond? There are the covalent bond is polar or non-polar, Sanoy? This is polar or non-polar?
Okay.
This is polar or non-polar?
They're non-polar.
This is non-polar. Okay. Which is more reactive, Sanoy? Polar or non-polar? Which is more reactive?
Okay. So polar is more reactive.
Polar is more reactive. So what we have to do, Sanoy, that is we need to make the compound polar. To make it reactive, we need to make the compound polar. Getting point? Yes, yeah.
Hmm.
So this
Yes.
we are going to produce the polarity effect in covalent bond. What are the factors? What are there? First one is inductive effect. Inductive effect. Inductive. It is the two types. That is plus I effect, positive inductive effect, minus I effect, negative inductive effect. Okay. Second one is resonance effect. Resonance. Resonance effect. Resonance effect is what, Sana? That is plus R effect, positive resonance effect, and that is minus R effect. That is negative resonance effect. Third one is hyperconjugation. Hyperconjugation. Hyperconjugation is one more term is called no bond resonance. No bond resonance. No bond resonance. The last one, Sana, electromeric effect. Electromeric effect. Electromeric effect means, Sana, that is plus E effect, plus E effect, and that is minus E effect. Minus E effect. So these are the what methods by which we can produce the polarity in the covalent bond. Inductive effect, it can be the one reason. Resonance effect, another reason. Hyperconjugation, another reason. Electromeric. These all effects, all used to what? All used to explain, all used to explain the stability of carbocation, the stability of intermediate. I am simply writing intermediate. Intermediate, it can be anything. Carbocation, carbanion, or free radical. This is okay. The first one I am taking this one. I am teaching you the hyperconjugation one. Okay. So I am hyperconjugation. 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 What is the hyperconjugation? Here in this case, hyperconjugation. The in this CH sigma bond, sigma bond, sigma bond form the pi bond, form the pi bond, and and the positive charge rotates, and the positive charge rotates, which makes the which makes the which makes the compound stable, which makes the compound stable. Since there is no bond involved, no bond involved in rotation. So it is called no bond resonance. Called no bond resonance. No bond resonance. greater the number of alpha hydrogen, alpha hydrogen, greater will be greater will be greater will be number of hyper conjugating structure. Hyper conjugating structure. Conjugating structure. Structure. And greater will be stability. Okay. That is we can write here. This is the proportionality sign, na? Proportionality sign. Greater will be stability. Greater will be stability. Will be stability. Greater will be stability. So you need to find the greater number of alpha hydrogen. Greater the number of alpha hydrogen, greater will be number of hyper conjugating structure, greater will be stability. Now, see one. Here is we are having this one. First, CH3. You can write in the different form this way. Here we are having C. This is the H. C. Here is H. This is the H. This is the H. I already taught you degree of the what? Degree of the carbocation, Virat. 1 degree carbocation.
No, sir.
No. I taught 1 degree, 2 degree, 3 degree. I taught. Wherever I explain the carbocation, I explain which is the 1 degree, which is 2
Sir,
degree.
1 degree, 2 degree, you mean, sir, that one, sir, that one was for both only, sir, not specially for carbocations. That was
For
for
all.
carbon and oxygen. So that you have taught, sir. I thought something else you were telling. So that are the types of carbocation and carbon ions. So you have 1 degree, 2 degree, and one you have methyl, which is also a type of 1 degree.
Okay, good. This carbon is called functional carbon. This is the functional carbon. What is this one? Functional carbon. Functional carbon. Okay. So functional carbon, and next to the functional carbon, this is called alpha carbon. Next to the functional carbon is called alpha carbon. This is what? Alpha carbon. This is what? Alpha carbon. Here, this one is called alpha carbon. This one, how many alpha carbon are there? Can you count? 1. Here is the 2, and this is 3 alpha carbon. 3 alpha carbon. Okay. Carbon attached to the functional carbon, functional group is called the alpha carbon. Okay. Now, if I will ask you, how many alpha hydrogen are there? Alpha hydrogen. Can you tell me how many alpha hydrogen? Number of alpha hydrogen. Hydrogen attached with the alpha carbon is called alpha hydrogen. Tell me.
Achha.
Hydrogen attached with the tell me how many alpha hydrogen are there in the glass?
One thing, sir, first let me please draw this diagram so then I'm telling you.
Done.
So in this first one there is 0, second one 3, third one is 1, 2, 3, 4, 5. This third one is 5, fourth one is
Fourth
the
one,
fourth one is 9.
9 alpha. So alpha hydro that is hyperconjugating 9 structure. It will give the 9 structure. So means positive charge will be distributed on the 9 structure. Then 6 structure. Positive charge will be on the 6 structure. Then positive charge will be 3 structure, and last one positive charge will be 0 structure. So I already told you, greater the okay distribution of the charge on the atom, greater will be stability. So stability of carbocation. Stability of carbocation means which is the stable? That is 1 degree. This is not the 1 degree, that is called methyl. This is methyl. Then it is 1 degree. Then it is the 2 degree, and finally it will be 3 degree. So it's stability order. This is the stability order. You will be able to understand stability. Getting this one?
Yes.
Okay. Here you see. CH3, if I will make this structure, CH3. So positive charge cannot go on the hydrogen. Is it as it is on the one atom? So it will be very reactive. Now in this case, you see, hydrogen, hydrogen, hydrogen. Here is C. This is the H, and here is the positive charge. One positive charge in covalent bond, means deficiency of deficiency deficiency of how many electron? Can you guess?
1.
2 electron. Suppose here you see covalent bond H, 2 electron, O, H. So these 2 electron is shared. This 2 electron is shared. Here they are shared. Now come back here. When it is splitting, so it is forming OH minus. 2 electron gone here, H plus. So in the circle of this one, how many electron is there? 2 electron. Now it is left with 0 electron. 0 electron. And it is the maximum. So one positive charge in covalent bond means how many deficiency? 2 electron deficient. Not able to understand.
Okay. Understood.
So it is 2 electron deficient. One bond means how many electron? One bond means how many electron? One bond equal to
2 electron.
2 electron. Thank you. So here, if you see this one, this is the alpha hydrogen. This is also alpha hydrogen. This is also alpha hydrogen. So what will happen? This is shifting here. So what will happen if it is shifting here? You see H, this will be C, here will be H, this will be double bond. And now, will there be the positive charge? In this position on this carbon, first carbon, suppose it is the first carbon, and this is second carbon. So first carbon now become how many bonds? You will find 4 bonds. So there is no deficiency here, and here it will become the positive charge because both the electron gone here. So there is no bond resonance. So earlier the positive charge are there on this carbon. Now the positive charge gone on the hydrogen. Are you getting this one?
Cannot.
Now see, this bond is going to be this place. This 2 electron bond of 2 electron going to take the position of this one. So what will be there? H plus P. This is the hydrogen. This is the hydrogen. This is hydrogen. This is hydrogen. So positive charge is here. Now, next case, this positive, this 2 electron is going to take the part here. So now check. what will be the here? It will be H. This is C. This is the H. Double bond C. Here is H. Here is H. This is the positive charge. So what you are going to find, the positive charge is not stagnant on any one carbon atom. Yeah, any one position. So it is very difficult to attack on that negative charge, yeah, a positive charge. What will be there? Positive charge is rotating total compound. Therefore, what we can say, deficiency on particular atom is less. Deficiency on particular atom is less. How many hyperconjugating structure are there? These are no bond resonance, that is structure is called. Here there is no bond, first structure, then second structure, and then third structure. So now the one positive charge is rotating on the 4 atom. One is on the carbon atom here, then second, third, fourth on hydrogen atom. So, this is the 3 hyperconjugating structure. Can you understand? No.
Understood.
Okay. So what the concept is there? Greater the hyperconjugating structure, greater will be the stability of the compound. Can you tell me what is the degree of this one? What is degree of this one? Carbocation.
Let me check.
This compound is like that. H3, CH3, H positive charge. What is 1 degree, 2 degree, 2 degree? What is degree?
Sir, this one the 2 degree only.
2 degree only, no? That is why I am asking. See, now what will happen? This electron is shifting here. So it will be H plus, right? Here is the carbon, double bond CH, and here is CH3. This is. So one structure we have drawn. Another time this structure is going to be. So what will happen? Here is the C, this is the hydrogen. Here is H plus, this is the hydrogen, double bond CH, and here is CH3. Next time this one is going here. So what will happen? This is the H, C, here is H, this is the H plus, double bond, CH, and here is CH3. So total, here is 1, 2, 3 structure. With one methyl group, how many structure we are getting? 3 structure. Now, see the next one. With the another methyl group, I am making another CH3, C. Here is the hydrogen. Here is the positive charge, but here the bond are like that. So this electron is going to be shift here. So first structure you see. This is CH3, C. Here is H plus. Here is hydrogen. Here is hydrogen. One structure. Now this will shift here. CH3, C. Here is H. Here is C. This is the H. Here is the H. This is the positive charge. Now next one. This time it is shifting. So what you are going to find? CH3, CH. Here will be the double bond. No? This is double bond. Double bond. What is the double bond? This is the H. So for maximum the rotation of positive distribution of positive charge. Maximum will be stability of the compound. Here. This is the 4. Here is the 5. And here is the 6. 6 hyperconjugating.
6.
So this is stable. Get it?
Sure.
See, here, if I will go this one, H, H, H.
Sir, I'm feeling actually we drowning. Can you give me 1 minute time? I lost my question. So it is here only.
Yes, yes, yes.
Just 1 minute. Yes, sir.
Hmm. See, here we are going. The first one. Can you tell me the degree of this carbocation? Can you tell me the degree of carbocation?
The first one is 1 degree.
First one is 1 degree.
Nah, 2 degree, 2 degree, not
Are
1 degree.
you
Two
sure?
or three.
Are you sure?
So let me check once.
If the carbocation is react with three
Yeah,
other,
so this is CH3, CH3. So this will be 3 degree.
this is also 3 degree, 3 degree. Total
All are three.
alpha hydrogen is 9. Alpha hydrogen 9. Alpha hydrogen 9. So in
Nine.
this case, it will form the first one form 3 structure plus 3 structure. Here is last one also plus 3 structure. Total will be how much? 9 structure. 9 structure. So 9 structure will be more stable. Getting? Suppose the first one I am making, if you see the first one, this bond is shifting here. So here is H, C, here is H, this will be the H plus, double bond C, here will be CH3, this is CH3. Next case, this one will be shifting here. So what will be the another hyperconjugating structure? H plus, C, the hydrogen, this is hydrogen, double bond, here is CH3, and this is CH3. One more possibility is there, this can shift here. So the another structure is also possible. HC, here is H, downside H plus, double bond it will be there, here will be CH3, and this will be CH3. So in what one methyl group, how many structure? 1, 1, and 1. So total becoming 3. Can you draw for this one, second one? Can you draw here for this one?
So sir, actually this type of structures I am not able to draw. Sir.
Nothing to do. One positive charge means you are saying no, one positive charge means 2 electron deficiency. Means this carbocation is less than 2 electron. It requires 2 electron. And you said one bond means 2 electron. So this 2 electron is shifting here. So once the 2 electron is shifting here, so what will find? That is total octet will be achieved, na this one. It will be octet 4 bond, 1, 2, 3, 4. So positive charge vanish and positive charge appear on what? The hydrogen atom. Okay. Now the
No, sir, now I can do. Now I
positive
can do.
charge distributed now. This bond will go here. So next structure you
So
see.
this one will be said like
See, here is hydrogen, H plus. Here is hydrogen. Now this will be shifting here. So another structure will be like that. CH3, C. Here will be CH3. Here is the double bond, C. This is the H. Here is the H. So now you in the structure, what you are finding? The positive charge is spreading. Deficiency is spreading on the many atom. So per atom it will be less now. Per atom what deficiency will be less.
yes,
So that
less.
per atom with deficiency less is more stable. This is one. This is one. This is one. Can you
So
draw now?
here we will have to put another H or what? So here is you have written nothing. Sir.
No, no, no. It got I erased now. That is why it got out. Can you draw this
So
one?
this one.
Can you draw for this one?
Yes, sir. Yeah.
Okay. Very good, very good.
So it is going away. So one.
No problem, no problem.
So done.
Okay, thank you. So that is correct. Total 9 hyperconjugating structure. Yes, sir. Greater the number of hyperconjugating structure, greater will be stability. Can you understand?
Hmm.
So if I will give you question here, which is more stable? Which is
Sir, can you bring the last slide 1 second? Sir, I had a question over there. Sir, here, sir, these three compounds are the same formula only, sir.
They all are the three, not three compounds, same. One time I open this methyl group. Another time I open this methyl group. And next time I open methyl group. These are the same compound. I just wrote open one by one. Otherwise, it will take too much of space.
That's it.
Yeah. Now, most stable and why? Okay, so second like C plus twice CF. Okay, tell the answer.
So the first one is the most stable.
Why first one is most stable?
So because highest number of carbon atoms it is having, so sir, that will mean the largest number, and that will mean sir, most repeated times we can do the sharing of that positive charge.
Very much. So one thing. Note hyperconjugation, hyperconjugation. But sound is coming. Hyperconjugation is not used stability of carbene ion. Carbene ion. That is negative carbon. It is used to explain stability of carbocation and free radical. Carbocation and free radical. The fan is working or what? Washing machine is working in your room.
Sir?
What is working in your room? Because sound is coming.
Because the fan is running. Sir, now it is okay.
Now it was it.
Sir, actually fan was running.
But it is too cold for running the fan.
Sir, here it is not that cold, sir.
Oh,
Here that much cold weather is not there.
okay. You write, can I erase this one?
Yes, sir. सही है. I will take.
Now, see here, if, if we will go stability of free radical, stability of free radical on the basis of hyperconjugation, the basis of hyperconjugation. Same logic is there, same logic. See, here is the how we are explaining this one. This is the free radical, right? In case of free radical, what is happening? Deficiency of only one electron is needed. So here two bonds are there. So one electron will go on it and another electron will making the bond here. These two. So here you see how you are going to find the structure. H, C, here is H, double bond, C, this is the H, this is the H, and here is H plus. Now, what the free radical are there on the only one carbon. Earlier the free radical are here, this carbon. Now it gone on hydrogen. Next time it can go here. So another free radical is going to appear here. H, here is H, this is H, double bond, CH2. Next time this bond is shifting here. So another free radical is how much, where it is going. This is the H, here is C, this is the H, here is free radical, this is CH3. So 1, 2, 3. So same rule is following now. For that is free radical, one electron is jumping on the where? Three different hydrogen. So three hyperconjugating structure, right? Suppose if I will go this compound, if I will ask how many hyperconjugating structure is possible? This one, can you tell me? So 3 with this methyl
Sir,
group,
I
3 with
think
this methyl group. So 6 hyperconjugating. Yes or no?
yes.
So 6 hyperconjugating. So stability order will be for the free radical. What will be the stability order? CH3 thrice, C dot, CH3 twice, CH dot, CH3, CH2, this one, and CH3, which is more stable. What will be the order? Okay, that is 3 degree more stable, then 2 degree, then 1 degree, then methyl free radical. Now, region, what is the region? Region is 9 hyperconjugating structure, 6 hyperconjugating structure. How much? 3 hyperconjugating structure, 0 hyperconjugating structure. So greater the number of hyperconjugating structure, greater will be the distribution of the scarcity of electron, greater will be stability. Got it?
Yes, sir.
So decreasing order of stability. Decreasing order of stability. Order of stability. What you do? You rejoin because 4 minutes left, it will be disconnect. Rejoin.
Okay.